Hello, seventh graders. In this video, I'm going to guide you in answering Activity A of Concard Physics. So, Activity A is about Newton's first law, which states that an object in motion will remain in motion and an object at rest will remain at rest unless acted upon by a force. So the force we're talking about here is the unbalanced force. So it's saying that if the force is balanced, so recall the tug of war we did in the classroom, if there's an equal force coming from two directions, then an object will remain in motion or an object at rest will remain at rest. But if there's an unbalanced force, meaning one force is greater than the other, then an object in motion will change its motion. Either it speed up, slow down, or stop. And an object at rest will no longer remain at rest, meaning it will start moving already. Okay, so let's see it in this activity. So we'll click the reset button and remove all the fans. So we already removed it. And then the question we need to answer is, what happens to the cart when there is no force? Or shall we say, when there is a balance force? So write your hypothesis first. So form hypothesis. What will the motion of the cart be like when there is no force at all? Meaning there is no friction in this model as well. Okay, what do you think it's gonna change its motion or it will remain to do its motion? And then number two, uh, predict. Suppose a cart with no fans has a starting velocity of 2 meters per second. So meaning it's an object in motion, meaning it's not at rest, just like the other situation in here. Uh, what will be the velocity of the cart when it reaches the wall? Is it still gonna be 2 meters per second or it's gonna be less or more than that? So write your prediction in here too. Now let's experiment. We're gonna check that there are no fans on the cart. On the description tab, you will set the initial velocity of the cart to 2 meters per second, meaning at the starting point, it's not at rest, it's already moving. And then we will select the bar chart tab and click the play, and you will see what will you notice about the velocity of the cart. Okay, so this is the graph that you're gonna be looking at. Okay, you can also show the numerical value of the velocity. All right, so let's start. So see this. So what is the velocity when it hit the wall? uh, is it the same or it decrease or it increase? So write your answer here. Number four, we'll experiment again. What if there are already forces acting on it, but we will place two fans on the cart and point them on opposite direction, meaning they're gonna apply force on different direction. So next to the direction, click the plus button for one fan, so we can make it face the other way, and turn both fans on, and we will click play and you will notice the velocity again. So we will reset, but this time we're gonna put fan A, don't forget to turn it on. Fan B, opposite direction, meaning negative, and don't forget to turn it on. So we're still gonna have an initial velocity of 2 meters per second. So we will see if it will not change its velocity, or it will slow down or speed up. Okay, what do you notice with the velocity? So write your observation in here. So in both situation, force is balanced. For the first one, no force is applied to the cart. For the second one, there are forces applied to the cart, but equal forces with opposite direction. So similar to the tug of war. that you and your partner are pulling the rope uh, at equal force. So did the rope move? So the same thing with the cart. It's already moving. Did it change its velocity? So did this change? So what do you notice about the graph of position uh, versus time? So let's now look at the graph. So select the graph tab. What do you notice about the graph of position versus time? Okay, so it's a straight line, as you can see in here. So recall, what does the straight line means? Okay, it's not a curve. It's not a horizontal line either. Okay, and then what does the velocity in time graph shows? So for the velocity, so as you can see, velocity is remained at 2. So meaning, did it change? Did it decrease or increase? Or did it remain the same? Next is, what do you notice about graph of acceleration versus time? So for the acceleration, okay, it's just at 0. So meaning, is there an acceleration or there's no acceleration at all? And lastly, you will now draw the conclusion for the Newton's first law. So Newton's first law states that an object in motion will travel at constant velocity unless acted upon by an unbalanced force. So how do these experiments show this? So you will explain how unbalanced force is applied to both situations, without the fans and with the fans, and what happened to the motion of the cart. Did it change in velocity or it did not change in velocity? Because what we're trying to prove here is the first law. An object in motion will remain in motion unless acted upon by an unbalanced force. And that's all for part 1. So after you do this, you may already submit your work in Google Classroom. Right here.